Okay, mean value theorem. Here we go. I like to call this theorem the Kansas Turnpike theorem. Please don't ever call it that to anyone else, or they won't know what you're talking about. Unfortunately, has anyone ever been on the Kansas Turnpike? Yes. It's a road that goes through Kansas. You have. It's a toll road, or it's a turnpike, which is sort of like a toll road. Yes, yes. It goes for a really long time. So when you get on the Kansas Turnpike, you get a little receipt or something. It shows how many axles you have.
Depending on how far you go.
Yes, and it shows like what time you got on the toll road and all of that. So when you get off of the toll road, you hand them your little receipt, and they tell you how much it's going to be, and you pay. So the question is, if you got there faster than you should, can you get a ticket? So let's say, just for the purposes of making this easy, this is for me right now. Let's see this. Okay, so let's say that the highway is 60 miles long. Now this is all theoretical, because it's longer than 60 miles. Well, how do you know all of this? Well, we do too, but I still don't know all that. Okay, let's say it's 60 miles long, and let's say the speed is 60 miles per hour. Then how long should it take you to get to the next booth? 1 hour. Let's say you make it in 45 minutes. Can they give you a ticket for speeding? Let's say for purposes of example, let's say you make it in 40 minutes. So you're supposed to be an hour, and you make it in 40 minutes. Can they give you a ticket?
No. They didn't talk to you.
No, they don't. But they know you really should. You go on at 40 minutes.
How fast were you going? Yeah, that's the next step.
How fast were we going if it was 40 minutes?
Yes.
60 miles in 40 minutes. So that's pretty good.
60 divided by 2/3. 90. Okay, so you're okay. So let me ask you this: what is 90 miles per hour? What? Sure, it's 30 over. What does it stand for? Was it the speed you were going the whole time?
Yeah.
It's the average speed. So your average speed would be 90 miles an hour. Could they give you a ticket for going 90?
You must have going like 130 and then slow down to 40.
Okay, so can they give you a ticket for going 90?
No, because they were going to go there and on 90.
They know you were over that
They know it's the dollar hit 90 and then that's all.
Yeah.
So can they give me a ticket for going 90?
They know for a fact.
What do y'all think? You're right.
I feel like I know where this theorem is going, but I believe that they know for a fact that we've gone at least 90. Because they know the average rate was, goes down or above. I think the technically good, but why they don't. The lowest maximum speed you have is 10 miles. I mean, the lowest minimum.
I don't know.
Because you did go fast.
So what I'm asking you,
Take the minimum speed you can go at. No. That's 2 times 40,
so can they give you a ticket? So let's make it consistent on this. Can they give you a ticket for going 90 miles an hour?
Yes, they give you a ticket for going 90 miles an hour.
Can they give you a ticket for going 91 miles an hour?
No. You could have gone 90 the entire time. They can give you a ticket for going 90 on the speed limit.
Well, you get tickets. Have you ever gotten a ticket for speeding? You have to hurry. They give you a ticket based on how many, or you have to pay based on how high over the speed limit you're going. So they have to know what speed you're going. So can they? The question is, can they give you a ticket for going 90? And you think yes? Raise your hand. 4 of you. If you think they can give you a ticket, oh sorry. If you think they can give you a ticket for going 91, raise your hand. Interesting. Okay. So mean value theorem, Kansas Turnpike theorem, also known as, if we have some function This is A, this is B. This is f of A, this is f of B. What I'm saying is that the average rate of change, f of B minus f of A over B minus A. In my picture, that looks like this. I'm saying that my average rate of change is equal to my instantaneous rate of change at some C, where C is in A to B. I think it's open parentheses. Okay. So your average, in this example with Kansas Turnpike, your average speed is equal to your instantaneous speed at least one point. This is what the mean value theorem says. Now the hypothesis for the mean value theorem is that it has to be continuous and differentiable. So let's write it out. This is one theorem that you need to know by name. You need to know since it has a name. If f is continuous on AB and differentiable on AB, then there exists a C in AB such that the instantaneous rate of change is equal to the average. So again, the two things we have to know is that f is continuous and differentiable. Then there exists some C that is an x value in between A and B such that the derivative, the instantaneous rate of change at that point is equal to the average rate of change. If we look in our example, it's probably somewhere over here. This would be our C right there, where the slope is the same as the average slope. So going back to our little Kansas Turnpike, the first thing we have to determine is driving differentiable? So a differentiable thing, the only thing that can mess it up with driving is if you have a sharp curve. So if we thought about time and positions, here's our position, here's our time. Will it ever be going like this? Will it ever make a sharp corner like that? Okay, it will still be smooth. It will still be a smooth curve. Because when you're stopping, because this is what you're doing, if you're going to have position stay constant, and that means you have to stop. When you stop, you're not just going to abruptly stop. Even when you hit something, you're going to slow down quickly, but you're going to go through all the values to get to zero. You're not all of a sudden just going to be zero. By the way, if driving weren't differentiable, if you could all of a sudden be zero, your body would just be gone. Yeah, it would be crazy. But anyway, so this is a differentiable function. Do you understand that? Driving is differentiable. Okay, so since driving is differentiable, and that's part of the hypothesis, this says that whatever our average speed is, we had to be going that speed at least one place. So can they give you a ticket for going 90? Sure. Can they give you a ticket for going 91? No, because they don't actually have proof that you went 91. Now, more than likely, you went 91. Because more than likely, you didn't just stay at 90 the whole way. Because when you go to the toll booth, you have to stop and get the receipts. So you're starting from zero, which means that you have to accelerate back to whatever speed you're going to go. So actually, you, I'm sure, went at least 91 at some point. And then to get to the next ticket booth, you have to slow down again. Make sense? But they can't really prove that. All they can prove is that you went 90 at least one place. Yes?
What I'm trying to say is your lowest maximum speed is 90. But you cannot have gone below 90. You cannot have network maximum going on the average.
Okay, so Rolle's theorem. You're going to see this in the book also. Rolle's theorem is mean value theorem, but where the derivative is equal to 0, which is the slope of the secant line. So Rolle's theorem is the exact same thing as mean value theorem. It's just a special case where the average was 0. Okay? I want you to go ahead and try the problems that are on 4.2. If you are struggling, that's okay, but you should be okay. Any questions before you leave? Right here? Is it here? Oh, yes, it's all subtraction. 7 10.